In Lesson 4, we practice reading the structure of carryovers deeply. A carryover can happen in any place value, and a carryover in one place affects the conditions of its neighboring place. Our goal is to understand how the conditions of each place are connected to each other. The goal of letter sum deduction is not just finding the answer. Reading the conditions, reasoning, and connecting them is the key. This process creates an algorithm. Before we solve problems, let's learn about the meaning of carryovers. I put 6 examples on the board. Observe them and share your thoughts on my questions. There is something in common among these 6 examples. Can you give an example of an addition that is different from these 6?
All 6 examples only have one addition.
That's right. In other words, they are addition sentences with 2 parts.
An example that is not a 2-number addition is a 3-number addition. We can write it as box plus box plus box.
Great job! There are not only 3-number additions, but also 4 or 5-number additions. Can you explain how many digits the whole has in these 6 examples?
When there is no carryover, it's the same as the number of digits of the larger part, like 1 digit for number 1 and 2 digits for number 2. If there is a carryover, the whole has 1 more digit than the larger part.
You jump to the conclusion that it works that way for all possibilities without even solving them. How did you figure that out?
I used what we learned before.
A carryover can happen in every place, or it can happen only in a specific place. Look at the examples below and explain in which place the carryover happened.
In number 1, a carryover happened in the ones place. It happened by adding the largest 1-digit number, 9, and the smallest, 1. In number 2, a carryover happened from the tens place to the hundreds place. And a carryover must happen in the ones place too. In number 3, a carryover happened in the tens place. In the ones place, a carryover can either happen or not. In number 4, a carryover happened in the hundreds place. For that to happen, a carryover must happen in the tens place. And for a carryover to happen in the tens place, it must happen in the ones place. In number 5, a carryover happened from the hundreds place to the thousands place. For this, a carryover must happen from the tens place to the hundreds place. In number 6, for a 4-digit plus a 1-digit number to become a 5-digit number, a carryover must happen in the thousands place. Since there is only one number in the thousands place, a carryover must happen in the hundreds place. Likewise, a carryover must happen from the tens to the hundreds, and also in the ones place.
You explained it better than I could. I feel great seeing you improve day by day. There is a fact we can know when the whole has 1 more digit than the part after adding 2 numbers. Can you tell me what it is?
The number carried over from adding 2 numbers is always 1.
That's right. I used the largest and smallest numbers in the examples, but it works the same way for other possibilities. When the digits increase by 1 after adding 2 numbers, the carryover is always 1. Let's see what we can figure out in numbers 1, 2, and 3. In number 1, find the box that you can figure out the exact number for, and tell me why.
We can figure out the hundreds and tens places. The hundreds place is 1, and the part in the tens place is 9. Also, the whole in the tens place is 0. Because there is a number in the hundreds place of the whole, which means a carryover happened from the tens place. There is only one number in the tens place part, but with a carryover of 1 from the ones place, it can create a carryover to the hundreds place. Therefore, the part in the tens place is 9, and the whole is 0.
Find the numbers we can know in number 2, and explain why.
We can figure out the rest except the ones place. The thousands place is 1. The part is a 3-digit number, and the whole is a 4-digit number. Since the whole has more digits than the part, it means there is a carryover. Since there is only one number in the hundreds place, there must be a carryover from the tens place to make a carryover from the hundreds to the thousands place. Therefore, the numbers for the box in the hundreds place can be 9 and 0. And the tens place numbers are also 9 and 0. A carryover must happen in the ones place.
Explain number 3 as well.
The thousands place is 1. A carryover must happen in the hundreds place. Since there is only one number in the hundreds place, a carryover must happen from the tens place, and the carryover is 1. Therefore, the numbers for the box in the hundreds place can be 9 and 0.
You explained it wonderfully. Now let's apply it to a real problem. Observe problem and solve it. Share your answer when you're done.
The hundreds place A can be 1, 2, or 3. Because we added the same 3 numbers but there's no carryover to the thousands place. The sum of the 3 numbers in the ones place is B, which is the same as the hundreds place. So there is no carryover from the ones to the tens place. There's no carryover from the tens to the hundreds place either. If A is 1, B is 3, and C is 5. If A is 2, B becomes 6, and the sum in the tens place becomes 10, which makes a carryover. So I'll cross out this possibility. When A is 3, the sum in the tens place is 15, which also makes a carryover. Let's cross out this one too. Therefore, A is 1, B is 3, and C is 5.
Great job solving it. But if you connect what you found further, you don't need to check all 3 possibilities for A. Try connecting what you noticed in the ones place to the tens place.
I see. B is 3A. The tens place is A plus 3A plus A, which equals 5A. For 5A to be a single-digit number without a carryover, A can only be 1. Because if A is 2, 5A equals 10 and that makes a carryover. Therefore, A is 1, B is 3, and C is 5.
If you connect what you noticed in each place to other places, you can solve it faster and without mistakes. Don't just try to solve it quickly. Build a habit of seeing how the numbers affect each other. Let's look at the statement. First, let's understand the meaning of the sum of 2 numbers. The expression, the sum of two numbers, includes all of the above. Second, let's look at the effect of the rule. If there is a carryover, the carryover is 1. When there is a carryover, there are two ways. Sometimes the number of digits does not change, and sometimes the number of digits changes. What we learned today is about when the number of digits changes after a carryover from adding two numbers. The fact was that when the total has one more digit than the parts, the highest place value of the total becomes 1. This applies to the addition of all two numbers. If you keep this in mind, you will be able to figure out the highest place value when there is a carryover and a change in the number of digits in multi-digit addition. Great job finishing Lesson 4. Before moving on to Lesson 5, watch the Logic Flow lesson linked to this series. It will help you understand the next steps much more clearly. Check out Logic Flow Lesson 1 below.